So welcome everyone, and welcome Fawzi from the ML for Ed lab, so working in Tanya Kaiser's lab on using machine learning to help education. So I got to know your tool for the first time in January, where you presented it during a conference that we had at the AI Center. And I thought it was very interesting. And so let's hear a bit more about it today. Thank you.
Right. So, hello everyone as well. So I want to present to you our work, Refine. It's published now at AI 2026. So I'm going to be presenting it in July. So we have this idea that feedback, we all know feedback is central to learning, right? But not any feedback. Feedback has to have a certain quality, it has to be high quality. It has to be, it has to clarify like the learning goals, and it has to evaluate the students on those exact learning goals. And finally, it has to give actionable advice for students. But then we have the problem that, yes, you give a feedback, but not every feedback of high quality is also good. It's not alone enough to be of high quality. You need to engage with the feedback. Students need to engage, use it, think about it. Otherwise, it's not helpful. But this is almost impossible when you have large classrooms, like 600 people, 700 people, 1,000 people in the same classroom. It's almost impossible, especially with large EPFL classrooms. So LLMs can help with that. The problem though with LLMs that most literature focuses on using closed source LLMs. You have your ChatGPT, your Gemini, all of that. And the problem with that is that we don't know anything about the data being used. We don't know anything about privacy. So this is one issue. Secondly, most literature right now focuses on using an LLM to generate a feedback, and they often miss grounding it in learning theory or feedback, literature, pedagogical grounding, this kind of thing. And you end up with hallucinated output, so it's not useful. So, and if you try to take all of that into account, you end up often with static feedback. So it's pedagogically grounded, you train your model, you do whatever, but at the end of the day, it's going to be static. The student going to get it, and that's it. This is also problematic. So that's why we have Refine. So what is Refine exactly? So you start with the problem. So a student has a problem, they solve it, right? They write down their solution. So we want minimal friction. If you ask the student to type it on their computer, sure, they can do that, but there is friction. It's annoying. So right now, they can, on like what we designed, basically, they can type it on their iPad in a handwritten piece of paper, upload it, get a feedback generated using an open source model, and then interact with the feedback. So whenever they have confusion, they have a chatbot that they can talk to about the feedback that they received. So what are our research questions? So the first research question is basically, can we build a multi-agent system using open source models that can basically generate a feedback and let students interact with this feedback? Again, open source, all controlled, pedagogically aligned, and no hallucinations or minimal hallucinations as much as possible. And then what do students ask when you give them a feedback? So this is also a question. We don't know yet when you give them an AI generated feedback, what happens? What questions do they ask? And then finally, okay, does the feedback that they get, does it shape or steer the questions that they ask? This is also important. Otherwise, there's no feedback uptake. So let me go a bit into details of how this is working under the hood. So we have the feedback generation agent. This is the first kind of component. You start with a question, the student solution, and the model answer. You give all of that to an LLM, but then as I said, LLMs hallucinate. And now we're using a much smaller open source model that is hosted on EPFL's infrastructure. So what do we do about that? So we first ground it in pedagogical theory. So we have Hatti's framework, where I'm going, how I'm going, and where to next. So basically tell the LLM, okay, don't generate just any feedback. Use this and use that pedagogical grounding to generate a feedback that is meaningful, that we know is meaningful from the literature. And then you generate a feedback report. But again, we don't know if it hallucinates. So we get another LLM that is going to judge this report. It's a human aligned, so we did many rounds of annotations to make sure that this judge LLM basically is factual and correct and would judge the feedback according to certain criteria. And then we go in this loop. So the LLM, the judge LLM, is going to give the reasoning for why this feedback is problematic or what is exactly flagged in this feedback and give it back to the generator LLM. And it would go in this loop until there are no more flags. And we get our nice feedback at the end. Then this is the interactive part. So first we're done with the feedback generation, and then we want the students to interact. We want them to ask questions. So again, how does this work? So a student would ask a question like this. This is a question about the mistake that they did in the feedback that they received. And we don't want the LLM, we don't want to leave it to its own devices. So we give it access to tools. Tools such what? Such, we have a textbook that is from the class, obviously. We have the slides, lecture slides, the schedule, and solved exercises. So what's going to happen is that the LLM is going to take all of these and then produce a tool call. So basically call one of these pedagogical tools that we designed. We know what's inside. It's deterministic. So the LLM can call them, but sometimes LLMs are not perfect. So sometimes they would use a wrong tool or something that doesn't make sense. So you get an error. But LLMs can think and can reason about the output. So we give this back to the LLM, and again, it will go in a loop until it figures out a final answer that is meaningful and correct. And then we give this final answer to the students.
Excuse me.
Yeah.
Can you push the Zoom window on the left or downward? Yes.
Sorry about this. Yes. There you go. So you have your nice answer from the LLM that is pedagogically grounded in our pedagogical tools. Yes. So in order to build this LLM, we had to train it, we had to fine-tune it on the data that was not available. We had to create synthetic data. So we started off with some MOOC data that was available from previous work. We generated some feedback reports off of that. We gave these feedback reports to a group of students to ask some questions. So we wanted to know how students would ask questions given a feedback. And then we annotated those questions according to HATI. And then we obviously found that many students were interested in course evaluation, basically what grade am I gonna get? And then we created the tools that I just showed you based on the questions that we got. So that's this. And then this wasn't obviously enough. That was about 70 questions. So we have our tools, we have our human data, and we went to a much bigger model, closed source, GPT-4o. And we asked it, okay, we want to simulate these questions. We want to simulate students. And we had various checks and measures to make sure that the distribution of those questions aligned with the distribution of the questions that GPT generated. So we have the synthetic questions, and we got GPT to think about these questions and basically do all these tool calls and generate reasoning chains and give us at the end a synthetic data set. And we evaluated the synthetic data set again with an LLM as a judge to make sure that it's correct and human aligned. Again, the LLM as a judge is human aligned. So we end up with a synthetic data set to basically train our model or fine tune it to do this behavior, the going in a loop and calling the different tools. So in order to evaluate refine, we had 3 modes of evaluation. Initially, we did an offline evaluation on 177 feedback reports from previous literature. So the LLM would basically look at the reports or look at the questions, generate the reports, and then another LLM would look at the reports, which is an LLM as a judge, and report the different metrics. And then we had 192 questions, simulating student questions, interacting with the LLM. And again, we evaluated the judge. And then we did a controlled in-class user study. After that, we did an unconstrained exam preparation use. Basically, students asked to use the system, and we gave them access to the system, and they used it basically, and we ended up with a data set that we could evaluate our system off. Yeah, so this is basically the study. Remember this is kind of how Refine works, but instead of them uploading any kind of question that they have. They can now upload, they can now answer, or we constrain the question to a certain discrete math problem. In class, they had 30 minutes to answer the question on a piece of paper, upload it, get a feedback, then interact with the feedback. We ask them to ask at least 3 questions. Then, so this is basically the study population. So we had 39 students, 26 male, 13 female students. It was basically in an EPFL classroom, took about 30 minutes. And then at the end of the study, students asked, they said like they wanted to use it for exam preparation. They found it helpful. So we uploaded 3 years, the past 3 years exams. They generated about 362 feedback reports, and 99 of them had at least 1 question. So students were kind of selected. So looking at the results, the takeaway here is that the refine loop, where you refine the feedback based on the judge, it kind of improves the feedback significantly across various metrics that look at the current state correctness and quality, the tasks that were given, this kind of thing. And this is from literature. And yes, so this kind of works. Also, so we end up using the Quint30B, quite smaller than the means of parameters closed source model. And we use the Quint3 A2B model, basically, again, much smaller in our interaction. And again, our training method kind of improved upon their base models. So what's interesting here is that we looked at the questions that students asked, like the themes of questions that students asked during our study. So we found that students ask in distinct themes, and you can group these themes into basically task, solution, kind of understanding the task, understanding the solution, or asking for the solution, negotiating the feedback, or asking more questions about the feedback, or asking for additional feedback to generalize for other questions, or obviously off-topic questions that any student would ask. To give you an example, this is kind of, they don't know anything. So the problem was about using, it was like recursion problem, and it was discrete mathematics. So this is, what are the steps of recursion? So they didn't really know anything about the problem. So they wanted to ask the bot how to do this, how to approach this problem. Here, they were like, okay, give me the perfect answer, the perfect solution, because they wanted to verify their solution. And then the feedback, obviously asking about the feedback. And then here, this is kind of generalizing. Is there a general way where we can do structured induction? And finally, this is one of the interesting questions. So the off-topic questions, you would think they are about like students are disengaged or they don't want to ask questions, but rather this student, for instance, was asking about dyslexia. So they have dyslexia, how can I deal with that? Which was interesting. So yeah, we graded basically the questions and looked at the different categories and how do they compare to the student grades. So kind of task makes sense. They don't know how to approach the task. They don't know how to solve it. So this kind of on the lower end of the spectrum. And then the feedback questions was pretty, yeah.
Sorry, I didn't understand that part. You graded the questions? What
Yeah.
did you grade? Sorry.
So the question, so when we did the study, so they uploaded their solution and they gave it to the bot to basically generate a feedback. So we took those solutions and manually graded them.
Ah, okay.
Yeah. And so yeah, so then we basically looked at the questions they asked.
Okay.
Those are like examples. Then we looked at the grades and how the grades compare to the different categories. How does a person who asks about task solution, how does like the distribution of their grades look like? Feedback was spread across the different kind of grades, which makes sense. Students are asking about the feedback, so most of them were engaged. Off-topic questions did not necessarily signal, as I said, lower performing students or any of that. But yeah, all in all, there wasn't like a significant difference. Again, because of the study, the number of students in the study wasn't large enough.
So can I ask again another question? So you graded the first submission.
Yes.
Could they submit several times?
No. So they submitted, they answered the question, submitted, and then interacted.
And then they had the dialogue.
Yeah. So yeah, and then when we left the students to interact with the system during their exam preparation, so in the first kind of study, it was in class, 30 minutes constrained. They had to ask at least 3 questions. But then in the exam preparation, they were left basically to generate the feedback whenever they wanted, and then interact with the feedback again whenever they wanted for how many questions as they liked. And we looked at the distribution of the question categories, and it was almost the same. Obviously, the off-topic was a bit less. They asked more about the grade. They asked more about the task, which was a bit surprising. They were preparing for the exam, so supposedly they would know how to solve it. But no, many students asked about how to literally like give me the answer, how to solve this. I don't know. Yeah, but apart from that, the distribution was almost the same.
Can you give us one more time some examples of feedback?
Yeah, I would love to see that.
Yeah, so
Questions about feedback?
yeah, these are like kind of the questions. I can show you some of the feedback that was generated as well.
Yes.
Yeah, let me.
Because these are questions asked by students as a follow-up. Right?
Yes, yeah. Yeah, so this is, I think on Zoom they won't be able to see it. Yeah. So this is kind of how a feedback would look like. It starts first with kind of the current state of the student, what they did wrong, what they did right. And then it will propose a bit of kind of next steps, this kind of following Hattie's framework. You should do this, you should do that. And these are kind of task changes, very specific to the task. And then after that, they would, the LM would give them a general strategy about how to approach this task in the future, and then some self-regulation advice. So how to generally self-regulate, how to study for this. Yeah, and at the end they would get something like a praise, and this is kind of following again the Hattie's framework for feedback. Yeah, at the end I can show you how it looked like in the UI. Yes.
I'm just trying to understand.
Yeah.
For the low performing students, but
Yeah.
also in general.
Yeah.
If I get feedback and then I start to talk further,
Yeah.
right? But the feedback also includes task specific.
Yeah.
So if you give me task specific or procedure specific feedback, then if I didn't understand the task, I'm going to negotiate on that, right?
Exactly. Yeah.
But how do you make the difference then in your categorization or in your themes?
Yes. So let me answer the question if I understand correctly. So basically, they would get like a task specific question. This is your question, right? So they task specific edit, sorry, in their feedback. And you're saying they're gonna ask about the task, right? Yeah. So this kind of falls under, it depends. So if it's about the task, understanding the task completely, they don't know how to approach the task at all. So it would be under the task category. If it's kind of asking about interpreting some of the aspects of the feedback, it will fall under kind of the feedback category. And within this, there's kind of interpreting, negotiating. So if the student is like, no, I think I'm correct and I think you're wrong, this is kind of falls under the negotiation of the feedback. And this still entails, let's say, a task that the LLM proposed, but the student is kind of saying, no, I think I did that correctly. I think you're wrong, this kind of thing. I don't know if this clarifies the question.
Yeah.
Thank you. Yeah.
Yeah. So, yes, is this all good?
It kind of also explains why the feedback category is so wide here, right?
Yeah.
Because it includes people who start negotiating about tasks that they didn't understand in the first place.
Exactly. Yeah. So
Yeah.
feedback kind of entails all of the any questions that are regarding the feedback in any shape. Yeah. And we only differentiate the feedback questions from the additional feedback. So if they go kind of beyond the task and they want an additional feedback about another question or trying to generalize how to solve this in the future, how to do this, how to do that in other problems. So this falls under additional feedback category. So yeah, and then we wanted to look at how kind of the feedback steers the questions. So again, we graded the questions, and when we graded them according to kind of three grading steps or rubric. So we had the basis verification, the inductive hypothesis, and the inductive step. And we looked at, okay, if the basis step was mentioned in the feedback, how likely is it that the students are gonna ask about it? So basically 89% of the time, students would ask about basis if it was mentioned in the feedback, if it was highlighted. And if it wasn't, it's 55. So basically the takeaway is that if something was mentioned in the feedback, students would ask about it, and kind of this somehow kind of is a proxy to feedback uptake. Means that the students actually read the feedback, understood the feedback, or tried at least to understand the feedback, and talked about it with the chatbot. So this is kind of a proxy to feedback uptake, and it's a positive thing, as opposed to just getting a feedback, static feedback, and not doing anything with it. So yeah, this kind of concludes the whole kind of refined pipeline, our study, our in the wild or unconstrained exam preparation setting. So yeah, kind of the judge refinement kind of feedback kind of improves the generated feedback from an imperfect model that is open source, that is much, much smaller than a closed source that we know nothing about its privacy. And again, the training kind of our interactive model closes the gap between open source models, small models, much bigger closed source models like GPT. Again, student questions kind of, again, in an unconstrained setting or within a class cluster into certain groups or categories. And engagement questions are usually about what was highlighted in the feedback. And finally, we did not measure kind of learning gains within our study. So this is something that we should do in the future. We would need larger sample space or a larger number of students to run the study with across an entire semester or so, such that we can measure if feedback or interacting with the feedback versus static feedback would improve learning. So yeah, that was it basically. Thank you.